identities also. So anyway, let's not waste any more time. Let's get straight to it. So this is a question that we're going to solve. By the way, if you didn't know, if you just joined, we are doing maximum and minimum values. Okay. For differentiation, I've taken out this worksheet. I've written the answers right next to every single question. I've shared this worksheet with you guys in the description. So go ahead, download it, do whatever with it you want. And without wasting any more time, let's get straight into it. Okay. So here's a question from May June 2011. We're gonna try and solve as many questions as we can in an hour, and yeah, that's it. After that, we'll all be on our respective ways. Okay. So as I said, this is a question from May June 2011, paper 11. Okay. So it says here the diagram shows a cuboid with a rectangular base of sides x centimeter and 2x centimeter. The height of the cuboid is y and its volume is 72 centimeter cube. Okay. Part 1 says show that the surface area a centimeter square of the cuboid is given by a equals to 4x square plus 216 upon x. Okay. Now, if you go about finding out the surface area of this cuboid, by the way, make sure that you guys have your formulas memorized. Okay, that's very important because you never know what shape that you're going to be dealing with, and there's no fixed pattern as to what formula you will be provided and what formula you're expected to know. So it's just a good idea to know all the formulas so that you're not counting on the examiner providing you with the formulas. Okay, so if you go about finding out the surface area of a cuboid, just make sure to look at the question and see whether it's an open cuboid or not, because that's going to change the formula slightly. Now, since it's not, we're just going to go about finding out the total surface area. So starting from the base and the top, so that's going to be 2x. So here's part 1. Okay, so that's going to be 2x times x multiplied by 2, and then the faces on the right and the left, so that's going to be x into y times 2, and then the faces on the front and the back, so that's going to be 2x into y times 2. Okay, now when you do this, you realize something. 2x into x is 2x squared, times 2 is going to be 4x squared, and then this becomes 2xy, and then this becomes 4xy. Okay, now you can simplify this further, but if you notice, if you look at what you've gotten and if you look at the way the question wants you to give your final answer, you'll realize that there is no y in the question. Okay, and that makes sense because you're supposed to give your answer in terms of x. So that means there's got to be something that the question has done to for you to be able to express y in terms of x, so that you can replace it with whatever it is in terms of x and give your answer in terms of x only. And that is the case. That is exactly the case. The question has done that by giving you the volume. Okay, so the volume of this cuboid is going to be 2x times y, and what is that equal to? That's equal to 72. Okay, so with the help of this, we can make y the subject, and y is equals to 72 upon 2x square. So 72 upon 2 is 36, and now we have 36 upon x square. So 36 upon x square is what we're replacing y with. So 4x square plus 6x into 36 upon x square. So 6 into 36 is 216. So area is equals to 4x square plus 216 x upon x square. So we cross out the x and we cross out the x square from the denominator. And now we have 4x square plus 216 upon x. Now, a question like this will usually be followed by that you will ask to, can we make 36? Oh no, you can't do that. You can't take the square root. No, you can't do that. Okay, so had it been y square equals to 36 upon x square, then you would have done that. But since it's y, you can't take the square root. Okay, so as I was saying, a question like this will always be followed by finding out the minimum value or the maximum value or the stationary value or something like that. Okay, so be mentally prepared. Once you do enough questions, you will realize that is always the case. Okay, so if we go to part 2, we realize just that. Given that x can vary, find the dimensions of the cuboid when a is a minimum. Okay, so here's a question for you guys. When you're finding out the minimum value or the maximum value or the stationary value, what is the one thing that you do? How did I get 36 upon x square? By making y the subject. Okay, using the volume. Okay, I'd rather not comment on that, whether I think the paper was easy or not. I don't want you to feel bad about yourself if you didn't do well. Okay, so let's leave it there. Okay. All right, so yeah, we differentiate and set it equal to 0. So if you're finding out the minimum value of a, you differentiate a with respect to x or whatever it is that you've expressed a using. Okay, differentiate it with respect to that, set it equal to 0. If you're finding out the minimum value of volume, then you differentiate volume, set it equal to 0. In some cases, it's going to be surface area like it is over here. So that's what we're going to do. So area is equals to 4x square plus 216 x to the power minus 1. Okay, so I haven't differentiated it yet. I've just made a differentiation ready. Okay, so dA upon dx, let's see what that looks like. So that looks like 8x minus, so plus minus 216 x to the power minus 1, so that's minus 2. That means dA upon dx is equals to 8x minus 216 upon x square. So we're going to set this equal to 0 as one of you said. So 8x minus 216 upon x square equals to 0. So now we have 8x equals to 216 upon x square. We cross multiply. So we have 8x cubed, which is equal to 216. We make x the subject. So x cubed is equal to 216 divided by 8. What is that? I think that's, let's find out. 216 divided by 8. So that's 27. X cube is equals to 27, which means x is equals to 3. Now don't get carried away and think this is the end of the question. You still have to find out the dimensions of the cuboid when a is a minimum. Okay, so as far as the dimension goes, remember the dimensions were 2x, x and y. So as far as 2x goes, 2x is going to be 2 times 3, so that's 6. As far as x goes, x is going to be 3. Now y was actually equal to what? 36 upon x square. Let's just double check. Yeah, 36 upon x square. So that means this, if you plug in the value of x, so 3 squared is 9 and 36 upon 9 is 4. So the dimensions were 6, 3 and 4. Yep, and there you go. That's it. That's your correct answer. Okay, now this question doesn't end there. Actually, there's another part to it, which is regarding small change. Okay, and since small change wasn't tested in the paper, so we should expect this to show up also. So it says, given that x increases from 2 to 2 plus p, where p is small, find in terms of p the corresponding approximate change in a, whether this change is an increase or a decrease. Okay, so it's asking you to find the approximate change in a, so that means you're looking for the approximate change in a. Okay, so what's the formula? The formula is approximate change in a over approximate change in x is actually equal to dA upon dx. Okay, and what's the value of x? The value of x that you're starting from is actually 2. Okay, so as far as dA upon dx goes, dA upon dx, we know what dA upon dx is equal to. That is equal to 8x minus 216 upon x square. So we're just going to copy paste that. Okay, there you go. So we're going to plug in 2. So dA upon dx when x is 2 means 8 times 2 minus 216 over 2 squared, which means 4. So 16 minus, okay, let's see what this is. 216 divided by 4. So that's 54. Let's see what 16 minus 54 is. So that's minus 38. So dA upon dx is equal to minus 38. Okay. Now let's go back and see what the question is asking for. The question is asking for the approximate change in A. So we have pretty much all the ingredients. We have the small, we don't have the small change in A, but we have the small change in X, which is equal to P, as it's going from 2 to 2 plus P, which is equal to dA upon dx, which is equal to minus 38. Okay, so if you cross multiply, so this is equal to minus 38P, and judging by the sign, you can tell that this is a decrease. There you go. That's it. That's your final answer. Okay. Okay, moving on. So here's a question. This is a 7-mark question, which I would like to solve. And this is from May, June 2012, paper 1, variant 2. Okay. Also, by the way, I can see that there are around, there are quite a few of you who haven't liked the stream. So if you guys could just like the stream, I'd really appreciate that. Okay. You're welcome, Zed. So here's question number 10. Let's see what it says. Question number 10 says, an open rectangular cardboard box with a square base is to have a volume of 256 centimeter cube. Find the dimensions of the box if the area of the cardboard used is as small as possible. Okay, so how does this work? Let's see. an open rectangular cardboard box with a square base is to have a volume of 256 centimeter cube. Okay, so if you look at a cuboid, okay, so as far as the cuboid is concerned, the volume of a cuboid is length into width into height. Okay, now this box that we're looking at has a square base. Okay, so that means 256, which is the volume. If the base is a square, so let's say that the base is x by x. Okay, so 256 equals to x into h. Okay, and what is that equal to? That is equal to 256 equals to x square into h. So what is h equal to? H is equals to 256 over x square. Okay, now as far as the area is concerned, area of an open rectangular box means x into x, so that's the base. So we're not going to multiply that by 2 because it's open, all right, plus x into h, that we're going to multiply by 2, and then another x into h, which also gets multiplied by 2. So let's see, what do we have now? We have x square plus 2xh plus 2xh, which is equal to x square plus 4xh. Okay, I can see that you guys are still discussing the paper. Okay, well, that's great. Okay, but thing is, there's nothing you guys can do about it now that the exam is over. And my suggestion would be to focus on what can come in paper 2. Okay, and that is what I'm doing right now. Okay, just a suggestion. Anyway, let's go get back to work. So we already have h in terms of x. Okay, so 4x into 256 upon x square. All right, and a is equals to what? X square plus 4 into 256, so that's 512. 512, double of that is 1024 over x, since the x from 4x and the square from x square gets cancelled out. Okay, so a is equals to what? A is x square plus 1024 x to the power minus 1. So we haven't differentiated it yet, we've just made a differentiation ready. And the next thing that we're going to do is we're going to set it equal to 0. Because why are we doing that, by the way? The reason why we're doing that is because you want to have the area of the cardboard used as small as possible. So that's like saying find the minimum value of a, and in order to find the minimum value of anything, you differentiate it and you set it equal to 0. Hello Maz, good to have you. So now we differentiate area with respect to x, which becomes 2x plus minus 1024 x to the power minus 2. So we write this nicely. dA upon dx equals 2x minus 1024 upon x squared. Thank you, Maz. Appreciate it. Hope the content is helping. 2x minus 1024 upon x squared equals to 0. Now we solve this. 2x equals to 1024 upon x squared. Cross multiply, so that's 2x cubed equals to 1024. X cubed is equals to 1024 upon 2. Which means x cubed is equals to 512. We didn't really have to do this. We didn't really have to do so many steps. Okay, you could have just jumped from here to here. Okay, so x equals to what? X equals to 8. Yes, thank you, Muhammad Anas. So now that you have the value of x, what is the question asking for? It's asking for the dimensions. Okay, so they're gonna be x by x. Okay, now remember, height is something that you still have to find out in terms of, because you have the height in terms of x. So the height was actually 256 upon x squared. So that means 256 upon 8 squared, which means h is equals to 256 upon 64. Let's see, what is that? So 256 divided by 64 is 4. Okay, so the dimensions are 8 by 8 by 4. And there you go, fellas. That's it. That's your final answer. Okay, now moving on. So let's do some of the more difficult questions. Okay, so there's a question that I've planned. Now this question, if you look at it, it might seem like an intimidating question, but it's actually not. Okay, sir, I wanted your opinion. After my A-levels, I want to apply to a top uni. Sir, I checked the requirements for some of the universities and they prefer further maths a lot. So any suggestions? Okay, if you think further maths is something that's really going to give you an edge, alright, then go for it. If not, then I wouldn't suggest you take further maths unless you're one of those who doesn't find AS math or AT maths challenging at all. If you find it challenging, then you would you would probably end up spending double the time on further maths. That means the rest of the subjects might get compromised. Okay, so while in isolation the subject is really good, it opens a lot of doors, but is it good for you? That's the question you really need to ask yourself. Okay. All right, so as I was saying, here's question number 21. Let's solve this question. This is from October-November 2013. Okay, let's see what it says. It says the diagram shows a box in the shape of a cuboid with a square cross-section of side x centimeter. The volume of the box is 3500 centimeter cube. Okay, so since it has a square cross-section, so that means it's kind of understood that this length that we're looking at will also be x centimeter. Okay. Sir, further maths is not okay. Good thing you deleted that. Okay. 4 pieces of tape are fastened around the box as shown. Okay, so let's look at those 4 pieces one by one. So here's the long piece of tape that you're looking at, and then you have 1, 2, 3. Okay, so 1, 2, 3, 4. All right, so here are the 4 pieces of tape that you're looking at. Let's see what the question says. The question says, given that the total length of the 4 pieces of tape is L centimeter, show that L is equals to 14x plus 7000 upon x square. Alright, now, so how do you find the length of the 4 pieces? Let's see. Let's start by this piece right here. Okay. This piece. What do you think will be the length of this piece in terms of x? Any suggestions? Yes, I do teach A-level P3 and M1. So you can expect M1 videos this year, but P3 videos maybe not. Okay. That I'll make next year. But M1 definitely this year you can expect. Okay, 4x. That's the correct answer. Good job. So you have 4x, and we're going to... Now, how many of these do we have? So we have 1, 2, 3. Okay, so we have 3 of these. So we're going to multiply that by 3. Remember, what we're looking for is we're looking for the total length of the tape that's used. Okay, so that's equal to what? That's equal to 12x. Okay, so plus, now let's talk about this this piece of tape, the longer one. Okay, the one that I'm now outlining in blue. Okay, so here's one length of the tape. Okay, here's another, and here's another. Okay, so what I'm going to do is I'm going to call the longer length, this length right here, equal to y. Okay, so as far as the perimeter of this tape is concerned, this is going to be x plus y plus y. Okay, how is it 4x? Okay, so it's 4x because it's sort of like a square where one side is x, and you have, since the square has 4 sides, so 4 times x is 4x. Okay, so that's how it's 4x. Okay, now, so if you find the total length, okay, which the question has called L, so we're going to do just that. So that's going to be 12x plus 2x plus 2y, which we can simplify further and call it 14x plus 2y. Now we've hit a problem. The problem is, as far as our answer is concerned, that has y, and as far as the question is concerned, that has answers in terms of x only. So that means there's got to be some information which allows us to express y in terms of x. Okay, let's see if that's the case or not. So if you look at the question closely, there actually is. Why? Because the volume of the box is 3500. Now, how would you find the volume of this box for any cuboid for that matter? So that's length into width into height. So volume is equals to length into width into height. Okay, now this being a cuboid with a square base means that the length and the width are going to be x each. So x into h is equals to 3500. All right, now if we make h the subject, so h is equals to 3500 upon x square. Now that we have the value of h, which we called y, okay, so I'm going to replace that with y. There you go, replaced with y, replaced with y. So we can replace y with that. So L is equals to 14x plus 2 into 3500 over x squared. Let's see, what do we get? So we have 14x plus 7000 over x squared. There you go, that's it. That's your final answer. Okay, so let me tell you guys something before we move on to the next question, that whenever you come across a question like this, maybe your immediate reaction would be that, oh, this looks so intimidating, this is so difficult to solve. But it's not always the case, okay? Sometimes, if you just try and look at the shape that's given to you, okay, if you try and get familiar with the question, it becomes a lot easier, okay? So whenever you look at a question, don't form an opinion about it immediately. Once you try and sort of get into the depth of it, it becomes easier, okay? All right, here's part 2. Part 2 says, given that x can vary, find the stationary value of L and determine the nature of this stationary value. So like I said earlier, that whenever you come across a question like this, the next part will definitely be followed by the question telling you that it can vary, and you are having to find the value of the stationary value of whatever, length, width, area, length, volume, area, whatever, okay? So let's do this question. Let's see what it says. So we have to determine the nature of the stationary value and also the stationary value, okay? Yep, we're going to differentiate it and set it equal to 0. So L equals to 14x plus 7,000 x to the power minus 2. So remember, I haven't differentiated it yet. I've just made it differentiation ready, and now I'm actually going to differentiate it. So dl upon dx is 14 plus minus 14,000, okay, because that's what minus 2 into 7,000 is, x to the power minus 3. Then we set it equal to 0. 14 minus 14,000 upon x cube equals to 0. Okay, so if you solve this, you get 14x cube, which is equal to 14,000, which means x cube is equals to 1,000. All right, and x equals to what? X is equals to 10. Yes, Munazza, that's the correct answer. Good job. But don't get carried away, and this is not what the question is asking for. The question is actually asking you to find the stationary value of L. So the stationary value of L you will determine by actually plugging in the value of x, which you just found in the original equation. So 14 into 10 plus 7,000 over 10 squared. Let's see, what do we have? So we have 140 plus 7,000 over 100. No, I'm not on Notability. I use this app called PDF Expert. So we cross out this 0 and we cross out this 0 with this 0. So 140 plus 70, that means L is equals to 210. And by the way, we also have to determine the nature. Okay, so how do we determine the nature? Let's determine the nature over here. Yep, we double differentiate. So for nature, we're going to double differentiate. So we already have what dl upon dx is. Dl upon dx is, let's see what that looks like. Dl upon dx is 14 minus 14,000 x to the power minus 3. Okay, so d squared L over dx square is equals to 0. Minus minus becomes plus, so 14,000 into 3. Let's see, what is that? 14,000 times 3 is positive 42,000 x to the power minus 4. Okay, so there's actually no need to plug in the value of x in this. You can sort of tell by looking at it what it's going to be, in the sense that whether it's going to be positive or negative. So 42,000 is positive. X power 4 can only be positive because the power is even. So that means this is minimum. And why is that? Because d squared L upon dx squared is greater than 0. Therefore, minimum. Okay. All right. So let's do. Sir, is it possible for kinematics, permutations, and vectors to come out again? Kinematics, no. Permutations, maybe. Vectors also, I don't think so. You can't have a paper with vectors in it twice. Okay. So again, this question also kind of looks intimidating, but it's not. Okay, so I'll leave a couple of questions for you guys to solve. Okay, and I think I'm just going to solve one more question. Okay, and then we'll call it a day. So let me pick out a difficult question. This question looks nice. How many marks is this? 4 plus 5, it's 9. Yeah, so let's do this. By the way, there's another stream I did for maximum and minimum values, and that is the stream that I did for students who are preparing for the advanced exam in May, June. Okay, so in that stream, you will notice that I've done questions like these. For example, I've done this question in that stream, and there are a couple of other questions that I've done. So you guys can watch that along with this stream, and hopefully, inshallah, this topic of yours will be covered. Okay, so this is a question from, let's see where this is from. This is from May, June 2016, paper 12. So not that recent, but not that old either. Let's see what it says. So it says the diagram shows a badge made of thin sheet metal consisting of two semicircular pieces, centers B and C each of radius x centimeter. They are attached to each other by a rectangular piece of thin sheet metal ABCD such that AB and CD are the radii of the semicircular pieces. AD equals to BC, which is equal to Y. Given that the area of the badge is 20 centimeters square, show that the perimeter P of the badge is given by P is equals to 2x plus 40 upon x. Okay, now here's a question. How do we find out the perimeter of this shape? Okay, so yeah, question for you guys. It says two semicircular pieces, centers B and C. So this part that you're looking at, what I'm highlighting now, is actually a semicircle. This basically. Okay, just a second. I'm gonna restart the app. Okay, because it's lagging. Yeah. Okay. We're back. So this sheet that you're looking at is actually, this shape that you're looking at is actually a semicircle. Okay, so if I want to find out the perimeter, let's see what all goes in finding out the perimeter. Okay, so I'm going to try and color code it for you guys. So let's start with this length. Okay, what is this equal to? This is going to be equal to x. Okay, so I'll write it down over here one by one. So x plus, and then we go with this length, okay, which is going to be y plus, and then this length, which is also x, okay, plus this length right here, okay, and that's actually this length, okay. So this length, which is also equal to x, all right, sorry, it's also equal to y, okay, so that means plus y, all right, and then we're gonna take the circumference into consideration, okay, circumference of the circle. So that's perhaps the only length for which we have to kind of work hard. So if you look at the length that I've highlighted in red, that's the circumference of a semicircle. So circumference of a semicircle is actually 2 pi r upon 2, so that's equal to pi r. Okay, I'll write it down over here. Circumference of a semicircle. Okay, now, so pi into r, which is equal to x. So if this is equal to pi x, it's understood that this length will also be equal to pi x. All right. So let's see, what do we have? So we have plus pi x plus pi x. Okay. Now, if you look at it, if you look at the question, if you simplify this, by the way, so let's see, what do we have? So the perimeter of the badge becomes 2x plus 2y plus 2 pi x. Okay, now the thing is, our answer contains only what? Our answer contains only x. So how do we fix this? So I'm just reading your questions here, by the way. We will consider two semicircle as a single circle. Yes, you can do that. Okay, so circumference plus 2x plus y, that's also correct, except it's not going to be 2x, it's going to be 2y. Okay, so these are the lengths that we have considered. So altogether we have how many lengths? We have 1, 2, 3, 4, 5, and 6. Okay, let's see if that's the case over here. 1, 2, 3, 4, 5, and 6. Okay, great. So far so good. Now the only thing that's left for us to do is to find y in terms of x. Okay, now let's see how we can do that. Let's see what information we have in order to do that. And yes, I can see that you guys have Munaza has shared the answer, and that is use area for y. Okay, so there's got to be something that allows you to find out y in terms of x, and in this particular question it's the area. Now as far as the area is concerned, let's see what we need to do in order to find out the area of this shape. So I'm just going to erase everything that I've done, okay, to the shape. So as far as the area goes, you can see that you have a semicircle. Okay, so the area of a semicircle is going to be pi x squared upon 2. Okay, reason behind that is x is the radius and it's a semicircle, so we do pi x squared upon 2, which means that the area of this semicircle under it will also be pi x squared upon 2. Okay, now what's left for us is to find out the area of the rectangle, which is going to be xy. So we have pi x squared upon 2 plus pi x squared upon 2 plus xy, and what is that equal to? That's equal to 20. Not according to me, but according to the question. So pi x squared upon 2 plus pi x squared upon 2 is equal to pi x squared plus xy, which is equal to 20. Now we have to make y the subject. So xy is equals to 20 minus pi x squared. Okay, now we make y the subject. So y becomes 20 minus pi x squared over x. So there's a lot of working that's required over here. And it's a 4-mark question, so that makes sense also. Okay, so a quick tip for you guys, and that is when you're doing this in the actual exam, so try and be as efficient as possible with the working, okay? With the space utilization, actually. Okay, so now that we have the value of y, we go back to the perimeter. So that's 2x plus 2. Now y we replace with 20 minus pi x squared over x, okay, plus 2 pi x. Okay, now there's a lot of simplification that's required. So perimeter is equals to 2x plus 2 into 20 is 40. So we'll separate the two. We'll write 40 upon x minus 2 pi x squared upon x plus 2 pi x. Now this is where everything magically comes together, and this is perhaps the most satisfying moment of questions like these. So the x from the denominator and the x squared from x squared gets cancelled out. So now we have minus 2 pi x. If you look at this, we have minus 2 pi x plus 2 pi x. So that means this gets cancelled out with this. And now we have the perimeter, which is indeed equal to 2x plus 40 upon x. And there you go. That's it. That's your answer. Okay, now we have the last part of this question, which says, given that x can vary, find the minimum value of p, justifying that this is a minimum value. Okay, so if, God forbid, you're unable to do the first part of the question, that does not mean that you can't gain these 5 marks. You can still gain these 5 marks by actually using the answer from part 1. Okay, so now we differentiate dp upon dx, which is equal to what? Which is equal to 2 minus 40 x to the power minus 1, so that's minus 2. And we set it equal to 0. 2 minus 40 upon x squared equals to 0, which means 2x squared equals to 40, which means x squared is equals to 20, which means x is equals to under root 20. And if you want, you can write this as 2 under root 5. Okay, now you have to find out the nature. So for that, we differentiate dp upon dx further. So let's write this nicely first. So dp upon dx is actually 2 minus 40 x to the power minus 2. If we differentiate it for a second time, we get d squared p upon dx squared, which is 0 minus minus plus. So that's plus minus 2 into minus 40 is 80 x to the power minus 3. And you can see that this is going to be a positive value, 80 upon x cubed. So since d squared p upon dx squared is greater than 0, therefore we will have a minimum value. So that's that. That's the end of this question. Yeah. And also the end of the stream. So a quick reminder for you guys. Let me reiterate the topics that you guys should study for the next paper. Okay. So differentiation, all right, including maximum, minimum value, also rates of change. Okay, then area under the curve, you should do that for sure. You're welcome. And then there is so you have to find p. Do I have to find p? Oh yeah. Oh, thank you. I still have to find the value of p. That's right. I just found the value of x, not the value of p. Okay, so let's plug in this value. Okay, I'll come back to what I was saying. Let's first finish this. So p is equals to 2 into under root 20 plus 40 upon x. So x I'm replacing with under root 20. Okay, so work this out. If one of you can just work this out and tell me what the answer is, I'd really appreciate it. I don't think you can get logs in P2. What you can get is linear log. Okay, so I'll do a I'll try and make a video on this also. I'll share it on my Instagram and try and post it on YouTube also. Okay, mentioning all the topics because I might end up forgetting to mention a certain topic. Okay, so but anyway, I'll let you guys know. I mean, I'll tell you guys right now anyway. So as I was saying, differentiation, maximum minimum value, area under the curve, you should do that. Linear law, should definitely do that. Then there is polynomials, should definitely do that. And I don't think there was a question on quadratics. I don't think I saw a question on quadratics. So you should probably do a question on quadratics also. Then there is polynomials. I don't know if I mentioned that. And also absolute. Okay, I don't think I saw a question on absolute values. Then there's also coordinate geometry, which you guys should definitely do. And also like normal integration, not just integration under the curve, but like just integration of trigonometric functions and all that. Okay, and yeah, I think that's about it. 8 root 5. Okay, thank you, appreciate that. So yeah, let me just double check. Functions, well, since surds, there was a question on surds, so I don't think we got discriminant in P1 and its curve. Okay, if you did, then that's great. Like I said, I haven't really had a good look at everything that came. Okay, so I will take a closer look and hopefully make a video on it. So next exam is on Friday, right? So today is Tuesday, so hopefully by tomorrow I'll have a video on it. Okay, so yeah, solving the paper, that's I can, but that's not such a good idea, so I wouldn't recommend. I don't think I'm gonna do that, and I wouldn't recommend that you guys watch a video of the solved paper either. Okay, discussing the answers in itself is kind of sometimes not an advisable thing to do, let alone solving the entire paper. Okay, the do not use a calculator in this question was not in P1. Okay, so if it's not in P1, that means it can come in paper 2. That's usually the case with polynomials where the question tells you not to use a calculator. Hello, Lee. Okay, so stopping here. See you guys, inshallah, very soon. I'll announce on my Instagram when I will be live next and also the topic that I will be covering. Okay, so see you guys in the next live stream. Take care. Keep studying.